so foggy out here. So today I'm on a mission. I want to find out the answer to one of my biggest questions, and that is, how do we get good, clean drinking water as a species?
Now, most of us probably don't think about that. You just turn on the faucet, right? Now, I'm thinking much bigger. New York City, for instance, uses 1 billion gallons of water a day. How do you provide that water, and how do you do it cheaply and effectively? We can't expect people to collect rainwater to drink. It falls in a watershed and then it's collected. But what's better for the water supply? A watershed of pig farms, or maybe grass? Or is it a forest of pines or oaks or maples? You see, there's a lot of questions.
And if there is any place to find answers to my question, it's up here at Coweta.
In the back of this valley within a USDA experimental forest lies the Coweta Hydrologic Laboratory. It's a high-tech facility designed to provide the best available science about water quality and quantity.
There it is.
It's been studying forests, climate, and streams since 1934, and there really is no better place to understand how water moves through a watershed. There are soil scientists, scientists studying climate above the forest, ecologists, and legendary scientists like Wayne Swank, often considered the godfather of forest hydrology.
Welcome to Coweta.
And I'm here to meet Peter. Peter knows his stuff. And this is awesome.
The first thing we did was head to a 3D map to get a feel for the Coweta watershed. Now here's an important concept to grasp. A watershed basically defines a drainage basin. So all of the water in a watershed will lead out of a specific area, and that means all of Coweta is a watershed. But within it are also smaller watersheds. But here's the cool thing. They can do experiments on each smaller watershed, and then, among other things, measure the water coming out of each one at its base at a measurement station. And all the colors on the 3D map represent different experiments they've done on the watersheds.
Watershed 6, this one's really interesting. They cut the forest and let grass grow for about 10 years.
But to understand how these experiments relate to which method is best to get good, clean drinking water from, we had to first go to the Data Processing Center, because here in the basement resides the archives. And possibly the biggest strength of this modern facility is that it's kept detailed, long-term data for over 80 years. And it's all right here in these books and notes.
Look in these records and you find little gems and treasures that people have forgotten over the years. It can do studies of how things have changed over the long term, right? So we've got data going back to 1934. We're still taking data today in the same location. December 7th, 1941.
December 7th, 1941, a date which will live in infamy.
Measurements of air temperature, the soil temperature, really say some pretty strong statements about how things have changed over time.
This long-term weather data is key. If you want to determine whether a watershed of grass does better than a watershed of maples by certain standards, then knowing the rainfall at that time is crucial. The other great thing is that these archives are full of photo evidence of each experiment.
So all of these photos are kind of showing the history of Coweta.
Mm-hmm.
Well, if we were to look at photos from there, and we go back there today.
So we could visit some of these same exact weirs and it'll look exactly like it does in these pictures.
So Peter and I started looking through the old pictures so that we could find one that we wanted to revisit today.
Alright, so here's what we got. We found this photo right here, which shows one of the watersheds that they cut and actually planted grass. And so in this photo, there's a little tiny building, a little structure that I think we can get to again. See what the watershed looks like today, right?
That's right.
So off we went up the valley, an absolutely breathtaking valley, whose slopes have changed with the passing of time. And as every year ticks by, we learn more about how water flows through each watershed differently. It's actually kind of amazing. You see, some of the watersheds exist as monocultures, like this one, white pine. They make you feel like you're in a different world. Others, mixed deciduous forest. Now our goal is to find the station in the photo on Watershed 6. And after quite a bit of driving, we found it. The same white building as the one in the picture standing right before us. I snapped a quick picture, and there before me I could see 75 years of change. And it definitely did change. But was it better or worse for the water supply? That's one thing I couldn't yet answer. To answer that, I had to understand how they study the watershed. And it all starts right here at the weir they built 75 years ago.
So this is a weir. This is a device that we use to measure stream flow. It's forcing all of the water from uphill, whether it's coming down the stream or if it's moving in shallow groundwater. It forces that water over this, what we call the blade, and through that notch. This pond is connected to a well through pipes, and so you can see the level of the water inside that well. And we have a float that sits on top of that water, and that float goes up and down with the level. When we measure the elevation of the water in this weir, we're measuring it every 5 minutes since 1934.
They measure the flow rate of the water chemistry, the sediment in the stream, and here's the gist of what they found. A watershed with trees actually uses more water than one with grass. Unless, of course, you fertilize the one with grass, then the watershed does use just about as much. But that's not the only thing you need to look at.
So there's the water supply and then there's the water quality aspect of it. Forests certainly will give you much cleaner water than any other land cover choices, such as agriculture or grasses.
It's still unbelievable that this used to be grass. Now we're getting somewhere. So I posed my ultimate question.
What is the best forest to have if you want good, clean drinking water? Well, it depends, I think.
I figured I'd probably get an answer about like that. I mean, forests are all different. They're pretty complex, and they're always changing.
Everything fits together so closely. It's all very interconnected.
But there are some things you can determine when you plant monocultures, like when you plant white pines.
These white pine ecosystems are using more water, which leaves less water in the stream.
Pine trees use a lot of water.
This is going to take some of that available water from your water supply.
And at the same time, if you want a lot of lumber quickly, then pines are great. But if we are concerned only with the amount of water, maybe pines aren't the solution. Then again, potentially we might be best concreting the whole valley.
You'd get the most water that way, but that's almost too much. It's like drinking out of the fire hydrant.
So forests buffer the water supply. They hold it when it rains and they slowly let it out over time. And that means the solution to my problem probably isn't in the form of just one species.
Diversification is probably your safest strategy.
And that's in part because a forest of one species could fall to disease. That'd be terrible. And secondly, we need to manage an entire forest landscape. There's a lot of other plants and animals in the forest, and they like the diversity a mix brings. Plus, if you're in charge of making sure a big city has good drinking water, you want it clean and consistent.
Over half of the population derives some drinking water from national forests. You want them to manage it based on the best available science.
I'm not sure if when I started I really thought there was just one answer. I mean, it really depends on what you're managing the landscape for. But it did allow me to get a better picture of this high-tech facility and all the interesting and complex science going on here. Like, what is going to happen with these forests with climate change or invasive species? And the answers to those questions are grounded in the important long-term studies here.
You don't know what surprises you might find in the record unless you have a long record over time in which to look for those things.
So let me wrap this all up for you. In the end, the answer to my question probably isn't an entire watershed of grass, or concrete, or even one species, but it's likely a mix. And we can have all of those cover types spread around our watershed, but it's about finding a balance. And the scientists here are studying how each type works in the bigger picture. They're utilizing these really crucial long-term data sets in combination with the current cutting-edge technology to now answer the big questions, such as, among other things, how do we best manage a forest to get good, clean drinking water?